So these are the half angle identities. So we have sine of t over 2, if t is any angle, sine of t over 2 equals plus or minus square root of 1 minus cosine of t over 2. So a couple notes here. These are just derived by taking the double angle formulas and sort of reversing them. So if we know the double angle, we kind of reverse engineer them and figure out what half the angle would be. And the thing that's different here is the plus or minus. So we're assuming we would know what quadrant t was in, and therefore we could easily figure out what quadrant t over 2 would have to be in. And then we would know whether or not sine of half of the angle were positive or negative. So it takes a little more thinking. So cosine of t over 2 is similar. It's plus or minus 1 plus cosine of t over 2. I'm sorry, square root of all that. And then tangent of t over 2 equals 1 minus cosine of t over sine of t. So take a second to write all those down. You absolutely do not have to memorize these. So here's an example of what we might do with these. We're going to use these identities to fill in some more gaps on the unit circle. So we're going to find sine of pi over 8 and tangent of pi over 8. You could also very easily find cosine of pi over 8. So the first thing to note is that pi over 8 is half of pi over 4, right? Just look at the angle pi over 4. That's like the 45-degree angle in the first quadrant. Pi over 8 is exactly half of that. And another way to say that is just to say pi over 8 equals pi over 4 over 2, like a compound fraction like this. And the idea being, we know what the sine, cosine, and tangent of pi over 4 are. We've known it for a long time. So if you look back up at the formulas, we're going to use those values to then figure out the sine and tangent of half of pi over 4, which is pi over 8. All right, so from that first formula, sine of pi over 8 is the same thing as sine of pi over 4 over 2, which means it's plus or minus the square root of 1 minus the cosine of pi over 4, which we know, over 2. So first let's deal with that plus or minus. Pi over 4 is in the first quadrant. Pi over 8 is just half as big as that, so that is in the first quadrant as well. So sine better be positive, and everything else is positive too. So pi over 8 is in quad 1. So that's what we mean. We just kind of have to think about where this angle is, and then that tells us whether or not it is plus or minus. Okay, so it is plus. So it's the square root of 1 minus, well, again, the whole point is we know that the cosine of pi over 4 is square root of 2 over 2. We've known that for some time, over 2. Okay, so that's the number. That's an ugly number, and now we're just going to do as much algebra as we have to in order to clean that up. So when you have a compound fraction like this, the easiest way to simplify it is just to multiply everything by the denominator. So I'm going to take the numerator and the denominator and multiply them both by 2, which I can do because I'm just multiplying the top and the bottom of a fraction by the same thing. So let's see. Up top we get, okay, that first term is just 1 times 2, which is 2. That second term, we kill the denominator. That's the whole point. So we cancel out that 2 in the denominator. 2 times 2 equals 4. And then we're going to clean that up even further by just rationalizing the denominator. So we can split that up into the square root of 2 minus the square root of 2 over the square root of 4. Which we don't have to really do anything to rationalize because the square root of 4 is just 2. So finally, the nicest form of that number is the square root of 2 minus the square root of 2 all over 2. So that's a lot of 2's. So what we have is this nested square root in the numerator, and what you'll notice is if you were to keep applying half-angle formulas to get, let's say, pi over 16, pi over 32, pi over 64, right? We can do all that now. What we would get is we would keep getting these nested versions of the square root of 2 inside of each other. So, you know, the nice thing again with these, don't forget you can just always check this. So plunge that into your calculator, you get a number that's about 0.383. And then just go ahead and punch sine of pi over 8 into your calculator, right? As long as you're in radian mode, you should get sine of pi over 8 is 0.38268343324, so you know it's right, but now we see what that number is exactly. We're going to do the exact same thing now for tangent of pi over 8. So if you look at that half-angle formula for tangent, tangent of pi over 8 equals 1 minus the cosine of, so the tangent of half of pi over 4 is 1 minus the cosine of pi over 4 over the sine of pi over 4. There's another version of this formula that you will probably see elsewhere, but this one is more useful to us. Okay, and the same deal, we already know these things. We know that the cosine of pi over 4 is square root of 2 over 2, and we know that the sine of pi over 4 is also square root of 2 over 2. So that's the number, it's just not the prettiest version of it. So we're going to clean that up a little bit by, again, we see the denominator is just 2 on the top and the bottom. So we're going to multiply numerator and denominator by 2 in order to clear that compound fraction. So that equals, let's see, 2 minus the square root of 2 over the square root of 2. And this actually simplifies quite nicely. So again, that's the right number. We just want to clean it up. So to rationalize that thing, just multiply numerator and denominator by whatever's in the denominator, which is square root of 2. And in the numerator, let's see, we get 2 times the square root of 2 minus the square root of 2 times the square root of 2, which is just 2. And in the denominator, again, square root of 2 times the square root of 2, which is just 2. I sure am saying the word 2 a lot. And look at that. That all just cleans up. The first term cancels to square root of 2. And the second term cancels to 1. So go ahead and punch that into your calculator. Remember what we're doing in the first place. I'm telling you that that's the tangent of pi over 8. So the square root of 2 minus 1 is about 0.414. And then just go ahead and punch the tangent of pi over 8 into your calculator. You will get the exact same figure. You'll get the same decimal. So you can always check these, but the point is, you know, not to get a decimal answer with any idiot with a calculator can do. We want to get an exact answer. So the tangent of pi over 8 is exactly square root of 2 minus 1. So here's another example. If a tangent of some angle t equals 4, and t is in quadrant 3, so t is an angle with terminal point in quadrant 3, we want to find the tangent of half of t and the tangent of twice t. So we're going to use a half angle formula and a double angle formula. So stop. If you haven't watched the video on the point in the plane definitions of sine, cosine, and tangent, get out of here, go watch that now, watch the example, and come back. So if you look at the half angle formula for tangent, it says the tangent of half of t is 1 minus cosine of t over sine of t. So we need cosine of t and sine of t, and we can't get that from just the fact that tangent of t equals 4. But here's how we can get it. The point -1, -4, must lie on T's terminal side. Let me convince you that that's true. So if you look at my diagram, okay, T is a point, T is an angle in quadrant 3. So we say we need this point because based on the point in the plane definitions, at least the one for tangent, we have, if we're kind of working backwards here, if tangent of T equals 4, and we have any point on T's terminal side, that means that the tangent of T is y over x, which in this case would be negative 4 over negative 1, which would be 4. So we're kind of reverse engineering. It has to be negative 1 and negative 4 because it has to land in quadrant 3. And then we're just sort of inventing this point, and then we're going to use this point on T's terminal side to get the sine and cosine of T. So using the point in the plane definitions to get sine and cosine, we first have to get the distance from the point to the origin. So that's the square root of negative 1 squared plus negative 4 squared, which is what? The square root of 1 plus 16, which is the square root of 17. So now we must have that sine of T is the y coordinate of that point, which is negative 4 over the square root of 17. And we must have that the cosine of T is the x coordinate of that point, which is negative 1 over the square root of 17. We could rationalize those denominators now, but we don't really need to. Let's just see what it looks like when we plug it into the formula for the half angle formula for tangent. So the tangent of T over 2 equals 1 minus the cosine of T, which is, let's see, minus negative 1 over the square root of 17, over the sine of T, which is negative 4 over the square root of 17. And now let's clean that up as much as we can. So that equals, let's see, 1 plus 1 over the square root of 17 over negative 4 over the square root of 17. That's a compound fraction, which means we want to multiply the numerator and the denominator by whatever is in the denominator. So it's 1 plus 1 over the square root of 17. To get rid of that denominator, we have to multiply both top and bottom by the square root of 17. So this actually isn't really like rationalizing. This is more like just simplifying a compound fraction. So in the numerator, we end up with square root of 17 plus 1. And in the denominator, we end up with just negative 4 because that compound fraction cancels out. And then that's it. That's the answer. There's really no reason not to bring that negative sign out front. So that's negative square root of 17 plus 1 over 4. So for part B, we're going to have to go back to the double angle formula for tangent, which I don't think we've used yet. And that says that tangent of 2t is 2 times tangent of t over 1 minus tangent squared of t. So notice this formula just puts you in the right quadrant without having to think about it. So we were given all the way back in the setup to the problem that tangent of t equals 4. So this is just 2 times 4 over 1 minus 4 squared. That part was easier. And that equals 8 over, let's see, 1 minus 16. 1 minus 16 is negative 15, so that's negative 8/15.